Okay, so the rod touches a metal sphere. Afterwards, the rod's charge is 8 nanocoulombs. If it was 12 nanocoulombs and it touched a metal sphere of 8, how come it's not 6 and 6? Let's see. Oh, I should do this randomly. La, 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 la. Oh, nope. That's 5, 1, 36. 25. 4, and you go. Why?
Because glass is an insulator.
Okay, there you go. Because the glass was an insulator, right? So it can't dump all of its charge. There you go. So what kind of charged particles were transferred between the rod and the sphere, and in which direction? So for A, if it was positive and the rod became less positive, then it must have received electrons. So what kind of charge was transferred? Electrons. And it went from the sphere. Oh, yeah, go away. Yeah. It went from the sphere to the rod. So what kind of charge was there, in what direction? And yeah, okay. Then for part B, how many charged particles were transferred? We know that Q is equal. We know that negative 4 nanocoulombs of charge were transferred. So Q is the total amount of charge. So what would you say? Q is like N times whatever. There's a way to write this, but I'm blanking right now. Is it QE or the fundamental charge? E minus? Yeah. The fundamental charge amount. So then the number of charges is going to equal to Q divided by 1.6 times 10 to the minus 19. All right, so nano is what, to the minus 9? So you get 4 to the minus 9 over 1.6 times 10 to the minus 19. So that makes it to the minus 10 on the bottom. So 4, so this would be, what, 16/4, that's 1/4, right? But then 1/4, so 2.5 times 10 to the minus 8, or what is it, something? Times 10 to the minus, is it 7 or 8? I don't know, I was just doing it off the top of my head. Okay, so I gotta do this myself. So, 10? Or 10 to the minus 10? Oh, yeah, sorry. The positive. Okay, there you go. Wait, to the minus 10? Yeah, if I, shouldn't it be to the minus 9? I mean, to the positive 9? Because 4 divided by 1.6 is, what, 1 over 0.4. So the 0.4, oh, okay, sorry. I didn't count for the 0.4. Okay, yeah, so 10. Okay. Yeah.
For this, it's 1.6 times 10 to the negative 19. What's 9.11 times 10 to the negative 31?
9.11 times 10 to the minus 31. That should be the mass of an electron, if I remember correctly.
What's this then?
This is the charge. Is it QE? Should I have written QE, the charge of an electron? The fundamental charge, little q maybe? What's that? It should be on your standard sheet, on your consa sheet. Yeah, sorry? The N stands for the number of particles. So this is kind of like the total number of eggs equals the number of dozens times how many per dozen, right? So if I tell you you have 10 dozen eggs, that means you're gonna have 120 eggs because you did 10 times 12. So this is the same thing. Wait, it's not the same thing. Oh, darn it. I was thinking of chemistry and avogadros.
6.25 times 10 to the 18 fundamental charges per coulomb.
6.25, oh, that other number?
Yeah, that should be the fundamental charges to coulomb ratio, right?
Um,
Because this is,
yeah, it should work the same way, because this is this many coulombs per charge. Right?
yeah,
So this is coulombs per charge. So then, if they gave us coulombs up here, then that's gonna cancel and it'll give me the number of charges.
Wait, and then the 420. Wait, why didn't we multiply by 2?
Multiply by what?
4 to negative.
Oh, because it's nano, yeah?
Oh. And then Q was
Yeah, Q is the amount of charge that was transferred. It should be the same number. Didn't you just say 6 point something, blah, blah, blah? So 4 times 6 point something, blah, 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 should give you about that number of charges? Right? 2.5 times 10 to the 10th? Okay, any other questions?